Hello everybody, welcome back to Physics with our Unit 2.07, Forces, Mass, and Acceleration. 3 things, 1 topic. Alright, inertia and mass. Inertia is the resistance to change in velocity. For example, when you're in a car and you suddenly accelerate and you get pushed back into your seat, this is inertia. Another example is if you're in a moving car, then you suddenly crash. Your body moves forward. Your body wants to keep moving forward. This is inertia. You are experiencing inertia, not the car, not anything else. It's you. When you are driving and you suddenly stop, your body doesn't want to change velocity. You don't want to slow down. You want to keep going. So that's why you move forward a little bit. And then your seatbelt's just like, can't do that. I'm here to save you. Alright. Resultant force. Resultant force is multiple forces simplified into one force. This is called resultant force. Here's an example. So it's 60 newtons to the right and 30 newtons to the right. So it becomes 90 newtons to the right. You just add those together. And how about the bottom one? Oh, that's a little tricky right there. 10 newtons to the left and 30 newtons to the right. What do you do then? Of course, you minus it, so it becomes 20 newtons to the right. Because 30 newtons is stronger than 10 newtons. So you just minus that. Alright. Important formula. An important formula of resultant force is force M and A. So it becomes F equals ma, which is also Newton's second law. The net force of an object is equal to its mass times its acceleration. That's Newton's second law. And you just gotta times mass with acceleration and you get the force. Alright. Next, an example. 1 Newton is the force required to give a mass of 1 kilogram and acceleration of 1 meters a second. So, you push with 1 Newton and that thing, it gets an acceleration of 1 meter a second. So there you go. 1 Newton, you push something that's 1 kg, it moves 1 meter in 1 second. That's what Newtons are. Alright, next. Some examples. How many Newtons is required to push a man that has a mass of 50 kg and give him an acceleration of 1 meters a second? We know that 1 Newton is needed to give 1 kg 1 meters a second squared. So we need 50 Newtons to give this man an acceleration of 1 meters a second. Why? Because this man is 50 kg, so therefore we need 50 Newtons to push him 1 meters a second. But what if we want to push him with an acceleration of 2 meters a second? Then we will need the force of 100 Newtons. Because, 50 times 2. 50 Newtons. That's the force needed to push him 1 meters a second. So we need to push him twice that force. It becomes 100 Newtons. That's pretty much it. Next, real life example. If Ali is falling with an acceleration of 10 meters a second and his mass is 59.9, then what is his resultant force? Disregard any air resistance. We'll use the formula force equals ma because we are trying to find his force. So his mass, m, is 59.9 kg and his acceleration, a, is 10 meters a second. So we need to multiply 59.9 with 10 meters a second and we will get 59.9 newtons. This is his final resultant force. That's a lot of force. He'll probably die. Alright. That's about it. I'm barely reaching 5 minutes, but that's okay because that's all that matters in this world, isn't it? 5 minutes. You don't need to learn anything. You don't need to do anything. You just need to reach 5 minutes. Alright, everyone, that's done.